Okay, so we come now to week 6. As usual, we'll have the quotations of the week. We'll get to those in a minute. But one of the big themes for this week is we're going to go back and revisit space-time diagrams, but in the context of the special theory of relativity, and see how they can be useful for us to visualize some of the key concepts of the special theory of relativity, and do a few more things with them as well. So we'll talk about lines of simultaneity and lines of same location. Lines of simultaneity really being lines on a space-time diagram of same time, and lines of same location being lines of same location. We'll talk about plotting a light beam on a space-time diagram and use special units for C that are useful. Then we'll move on and do something that's going to be a little strange, probably, and that is what I call non-square plotting. I don't know if it has another name, but we'll just call it non-square plotting. In other words, normally, of course, we have our axes when we're plotting at right angles. They don't have to be at right angles. You can actually have them at any angle you want, as long as you're consistent in how you do your plot. And you might say, well, why in the world would we want to make things more complicated like that? Well, the answer is, our next goal here, one of the big goals for this week, is seeing how to combine two frames of reference into one plot. We've talked a lot about Alice and Bob, Alice on a spaceship moving, or Bob on a spaceship moving, the other one observing, and the different frames of reference. We've seen the Lorentz transformation to transform back and forth in terms of the numbers. If Bob has, in a spaceship going by, measures an event at a certain location and a certain time along the x-axis, in his frame of reference, we can transform that event into a location and time in Alice's frame of reference. And it turns out we can actually get both of their frames of reference onto one plot, as it were. Really, it's really two plots in one. So we'll spend some time learning how to do that, and then seeing how we can actually visualize time dilation and length contraction and the relativity of simultaneity by using this method. Then we'll move on to regions of space-time, still really under space-time diagrams, but talk about something called the light cone and the various regions of space-time. We'll end up with a theme really of faster than light travel. The overall theme we've given for this week is breaking the space-time speed limit, in a sense, or breaking the ultimate speed limit of light. So we're going to consider, is it possible to have faster than light travel? We'll look at an example where it seems that something is moving faster than light, a spaceship, but actually isn't. And then we'll move on finally and look at a case where something really is moving at the faster than the speed of light, at least in a thought experiment, maybe not in reality. But we'll look at that in a thought experiment and look at how it affects cause and effect. So we've got cause and effect, or vice versa, in terms of that. So that's where we're heading this week. And then also heading on then to some of the other paradoxes we'll get into in week 7, such as the twin paradox and the pole in a barn paradox. And we'll find in those cases too, space-time diagrams, the things we're developing this week will be helpful for us to understand some of those things. So the quotations of the week, just two short ones for this week. Einstein said that the mainspring of scientific thought is not an external goal toward which one must strive, but the pleasure of thinking. Right? So just the challenge itself of thinking. Again, we go back to the struggle to understand that that really is the mainspring of scientific thought. It's not some external goal, but it's the pleasure of thinking itself. And then in terms of thinking, Einstein, of course, his original language was German. He did know some French, learned a little bit of English, but never really studied it intensively. Had, 300, 400 words. He could converse in sort of scientific terms. But evidently when he needed more time to think about a problem, especially when he was living in the United States in his later years, sort of 1930s on roughly, he would say in somewhat broken English, I will a little think, or I will a little think. And so you can say that to yourself sometimes if you need, where you just need, I need to think about this a little bit more here, try to crack the problem that seems insoluble. So that's where we're going this week. And again, very interesting way to visualize some of the things going on with the special theory of relativity.